In this question, we're looking at a block of mass 5 kilograms. It's being pulled along a horizontal plane by a force of 20 newtons. So, here is my horizontal plane. I have my block, which I'm representing as a point. We're told it has mass 5 kilograms, so we know that the mass 5 kilograms is going to give us a weight of 5g operating downwards. That means I have the normal reaction in operating perpendicular to the surface. We're told that it's being pulled along by a force, and the force of 20 newtons is inclined at 30 degrees to the horizontal. So I have 20 as a force going upwards at an angle of 30 degrees. So, next thing I know is that if I'm pulling it across to the right of my screen, then friction is operating in the opposite direction. We know friction is equal to the coefficient of friction times the normal reaction, and in this example we're told the coefficient of friction is 0.3. So we have 0.3 N. Okay, so what can we do? Looking at my diagram, what I've got, again, is a force that is an angle to the plane. We have got a right-angled triangle again. In that right-angled triangle, we have an angle of 30 degrees, and we have a hypotenuse length of 20. That means if I go to resolve that, what I will have is a horizontal vector that has a magnitude of 20 cos 30 degrees, and it has a vertical vector of 20 sine 30 degrees. Like the previous example, we do not write the vectors or forces in those positions. Where I'm going to do is write those components along the axes. So, I have acting vertically upwards 20 sine 30 degrees. Because I have resolved that force of 20 into its horizontal and vertical components, it is no longer used in my calculations. So what I'm going to do is look at writing down the equation of motion. R equals ma. So looking at our diagram, in yellow we're going to consider all the horizontal forces. We have, acting in the positive direction, 20 cos 30 degrees, and in the opposite direction to that we have the friction 0.3. So I have 20 cos 30 minus 0.4. In the vertical directions, we have n going upwards, we have 20 sine 30 degrees going upwards, and we have the 5g going downwards. We have n plus 20 sine 30 degrees minus 5g. The yellow highlighted parts are in the I direction, the green highlighted mass times acceleration. Now the mass we were told was 5, the acceleration is A. So what do we do here? We equate coefficients. We have 20 cos 30 degrees minus F. F is friction. Friction is mu times N. We know that mu, the coefficient of friction, was 0.3 N. Now that will equal the I components on the other side of the equation. Now, the only I components over there is 5a. So, what do we know here? Cosine of 30 is root 3 on 2. So we've got 20 times root 3 on 2, which gives us 10 root 3 minus 0.3 n equals 5a. This gives us an equation that has two variables in it, n and a. Now consider the second part of the equation of motion, the part that's highlighted in green. We have n plus 20 sine 30 degrees minus 5g equals the j component. Well, the j component, there is none, so it equals 0. So let's see what we can do here. We have n plus sine of 30 degrees is a half. 20 times a half is 10. Minus 5g. G is 9.8. 5 times 9.8 is 49. So we've got minus 49 equals 0. What we can then do with this second equation is solve for n. N is equal to 10 minus 49 degrees, which is minus 39, added on to 0 gives us 39. So a normal reaction is 39. We can then say, right, we can find A by substituting into equation number 1. We get 10 root 3 minus 0.3 times 39 equals 5 times A. Solving for A will give us 1.1 meters per second squared.